So, good morning to all of you, as well as good afternoon to those who are staying in India. The topic that I have chosen to discuss today or to deliberate today is on Joshimath Town Sinking, an insight from field-based analysis. So this is the content that I'll be discussing on, covering introduction, timeline of subsidence issue in Joshimath, studies conducted on Joshimath. Then here, my primary intention is not only to show what we have done, rather I wanted to compile all the work that has been done on Joshimath, because there are so many research institutes involved with study of Joshimath event, and everyone has got some nice viewpoints and some new insight into this particular phenomena. So I thought, why not I compile all the reports as well as their statements as well as their work, so that we get a holistic view of what exactly happened in Joshimath. So starting with this introduction, so here I have used one recent geological map of Joshimath area. So this is after Mukherjee et al. And published in Gondwana Research. Here you can see clearly that this is where Joshimath is located, next to Munshiari Thrust as well as Vakrita Thrust. So if we explain the location of Joshimath, Joshimath town is situated in Chamoli district of Uttarakhand, India. And it is very vulnerable in terms of natural hazards, mainly geohazard as well as hydrological hazard. You might have heard many incidences which took place recently. For example, the Chamoli disaster, the recent subsidence of this town. There were some earthquakes also which were triggered. Many heavy rainfall or cloudburst has been reported in this particular area. So it's a hotspot for many hazards. If you look at its location, it is situated on an east-west running Himalayan ridge to the southwest of the confluence of the Holiganga and Alaknanda at Vishnuprayag. And there are two intracontinental thrusts. One is the Munshiari thrust, which is given here as MT, and the main central thrust, Vakrita thrust, which is given as VT, located adjacent to the Joshimath town. The town mainly it lies on highly water-saturated paleo landslide debris, which in turn overlies highly fractured and sheared schist gneiss and quartzite. So this thing has been discussed many times. You have seen through many newspapers maybe, or even you have gone through many literatures also, where it has been reported that the town is located on a highly water-saturated paleo landslide debris. This is one particular map that I have taken from the geological and structural study done by Wadia Institute of Himalayan Geology. So this is what is Joshimath town, which looks like, and it is sloping towards north. So we have Vakrita thrust, which can be mapped somewhere here, and then we have Munshiari thrust. Let's look at the timeline of subsidence issues in Joshimath, how exactly it has taken place. If you look at the timeline of Joshimath subsidence issue, this is not a new phenomenon. Rather, it has been reported way back in 1976. Even before that, it has been witnessed. So in 1976, Mishra Commission or Mishra Committee, they have witnessed gradual sinking, and it was documented first. The report highlighted the fact that Joshimath town is situated atop an ancient landslide, which serves as the primary cause of instability in the area. So since it is located atop an ancient landslide, that could be the primary cause because of which there is instability in that particular area. In the year 2006, another important report came up from Dr. Swapnamita Chaudhary. She conducted a field survey between October 15 to 19, 2006. At that time, she was working as scientist at DMMC Uttarakhand. So her report on Joshimath localized subsidence and active erosion of the AT Nala, it clearly brings out the problem of subsidence that was taking place continuously in that particular area. Her study was more focused towards the eastern part, but the recent incidents that you have heard of, it's in the western part of the Joshimath town. So this study was more into the eastern part. So on 7th of February 2021, there was a massive debris flood which occurred in this area, creating a flash flood-like situation in Rishiganga River, and it extended downhill towards the Joshimath town. So I think you all have heard about the Chamoli disaster or the Rainy village disaster. There was one rock ice avalanche which took place and which damaged two hydropower projects as well as killing more than 200 people maybe. So that flash flood also has massively damaged, or it triggered somewhere this whole incident. The first indication of subsidence appeared a few months later after the Rishiganga debris flood, when cracks on the roads and some of the houses in Joshimath were first noticed. You might have heard about some houses where damage took place. So it was in news. So the first indication of incidence of subsidence took place, it came into news later on. On 18 October 2021, Chamoli district received the heaviest rainfall of 81.9 centimeter in a short span of 24 hours. of which Joshimath recorded a maximum of 18.5 centimeter. So this is according to the IMD special press release 2021, as well as you can browse to this particular site also where it was given. After 3 days of incessant rainfall, leading to increased cracks and subsidence along the roads and widening of earlier cracks, lots of cracks were reported in both Sunil as well as Ravigram wards. So two wards. So like if I look at this particular report of Dr. Swapnamita Chaudhary, where she has talked of eastern part, for the first time on the western part, which was believed to be more stable, here the development of cracks were reported in Sunil as well as Ravigram wards. Later on January 2 onwards, 2023, sudden appearance of cracks on the ground and houses were reported. Two multi-storied hotels tilted on each other, which had to be later demolished. And at the same time, underground water started gushing out at a location in Marwari. So you have seen many pictures or many photographs in newspapers where two hotels it started tilting towards each other, which were later demolished also. And then there was an issue where it was told that water is gushing out from one particular location in Marwari, where the discharge was close to 600 LPM during that time. From the first week of January 2023, the ongoing subsidence phenomena was observed in almost all the wards of Joshimath town. Initially, it was started in western part, and then it was observed almost in all the wards of Joshimath town. I'll show you a few pictures also, interesting pictures also. So this is a report of Swapnamita Chaudhary, where she has mapped all the channels, okay, all the channels, because there were total 9 nalas covering 28 kilometers, and Municipal Corporation Joshimath has stone pitched or made concrete a total of 3.5 kilometers of 3 natural nalas out of the 9 nalas in the region, because it was being told that we need to stone pitch or made concrete all these drainages so that there is no erosion, side bank erosion is not there. It is also suggested that all the nalas be pitched, especially in areas where nalas have been scarring the sides. Immediate attention is required for treatment of these nalas, according to that particular report. In response, she has written that there is construction of concrete drains of total of 8 kilometers within the town of Joshimath has been done by Municipal Corporation Joshimath. It has also stated in their memo, okay, that dated 18 October 2006, that regular cleaning of these drains is done by the municipality. However, Dr. Chaudhary, she has emphasized that there is a need of better cleaning of these drains in the town, which is locally, these are called as nalas, means drain, and proper disposal of the household wastewater is required. So it means all the efforts were already being done by the state governments. Still, there was some more need of some effort. This is a very nice picture that I have, a figure that I have taken from the paper published in Journal of Geological Society of India by Shantanu Sarkar, Shubham Das, Swapnamita Chaudhary, and Ranjit Kumar Sinha. So this is a cross section which tells about the location of Joshimath. You can see location of Joshimath here. Here is the MCT1, the first trust, and here we have P trust, PT, which is the Pandukeshwar trust. So Joshimath is located somewhere here. Now let's summarize the studies which were conducted on Joshimath area. So if we summarize different types of studies which has been conducted on Joshimath area, so we can find 4 headings. One is field survey, remote sensing based survey, geophysical studies, and hydrological investigation. There are some 12 to 14 papers that I have gone through which were published on this particular incidents. Most of these papers are based on remote sensing based studies. Only 1 or 2 are based on field survey. So starting with IIRS, Indian Institute of Remote Sensing, they have done SBAS interferometry, DINSAR, then application of course data. So with that, they have tried to conclude about this whole event. National Geophysical Research Institute, what they have done, they have used satellite-based SAR interferometry. They have also done some ground studies, not some, but lots of ground study. Among them, the prominent are EVRI, which is Electric Vector Resistivity Survey, multi-channel analysis of shear waves, MASW, and ground penetration radar or GPR survey. CGWB, Central Groundwater Board. Central Groundwater Board, they have done electrical resistivity tomography or ERT survey of that particular area. They have also monitored the cracks, spring location, and hand pumps, and they have also done hydrochemical study. The Wadia Institute of Himalayan Geology, they have been present there for quite a long time. They have been studying in that particular area. So they have done geological and structural studies, which includes mapping of cracks and displacement mapping. They have also done airborne high resolution up to 5 centimeter LiDAR mapping. So out of that, they have provided the DEM as well as DSM, classified data and ortho images to USDMA. And on request, USDMA is also providing, on genuine request, they are also providing this particular data. The Wadi of Himalayan Geology also conducted electrical resistivity tomography or ERT, and they have installed 11 close-spaced seismometers in that particular area. National Institute of Hydrology, they have done a very interesting study of that particular area. What they have done is they have mapped the springs and then they tried to find out the flow behavior of gushing water. They did hydrochemical study and bacteriological analysis, which was quite important because they have actually nullified few of the hypotheses which were related to anthropogenic contamination as well as related to the Tapovan Hydropower project. Geological Survey of India have done distribution and pattern of old and new cracks. They have also mapped natural springs and seepage characteristics. Site survey for relocation, they have been doing it because now the plan is to relocate few of these township or few of the people in this town to a new location. So geological mapping on 1:5,000 scale is going on. CBRI did safety assessment of buildings, damage assessment of buildings. IIT Roorkee, we have done PS INSAR based data processing, COSI core based method of measuring ground deformation we have done. This is not part of the report. This is part of our paper that we have published. Then our team have submitted a report which consists of study of shear strength characteristics of soil as well as determination of the bearing capacity of the soil. So apart from this, all of the other thing you can find out from the different reports which were submitted to USDMA as part of their initial analysis of Joshimath sinking. So this is the study area as it looks like. So here, this figure shows different municipal boundary and wards of Joshimath town. And this particular picture is taken by drone image of Joshimath town from one particular angle. And this is PS INSAR based study for the deformation which took place in Joshimath area. So for this analysis, what we have done, we have used 83 Sentinel-1 datasets between 12 May 2016 and 17 September 2023 for quantitative assessment and estimation. Beyond that, we have used the recent land subsidence activity 29 datasets from the years 2023 to 22 to 23. For comparative analysis of the observed land subsidence in the region, 12 SAR datasets forming the interferometric stack for the year 2016 and 2017 were also used. 24 SAR interferometric stack datasets for year 2018 to 19 and 16 time series SAR datasets of the year 2020 and 21 are used for further comparing them with the estimated land deformation. So this is result for one particular time frame, which is from 2022 to 23. And this color schema, it shows the deformation velocity in millimeter per year. And the red block shows the study area for which we have done this analysis. So in result, we have seen that the whole deformation history which has been reported till now about Joshimath town, it has a real concern with rapid urbanization. So we tried to find out urbanization using different data sets right from Corona series of data of 1970, then 1980 Landslides series of data, 2006, 12, 17 and 23. And we could see a sudden increase in urbanization in this Joshimath township. So this urbanization has actually put lots of loading effect of buildings and infrastructure on that particular slope. This is just a schematic diagram that shows what exactly could have happened according to us. So the possibility is there is infiltration in this upper part. There is possibility of wastewater as well as sewage going inside also. There is surface runoff also. Then we have new construction which took place in this particular area. So loading effect of buildings and infrastructure. All together, this has contributed to the subsidence as well as sliding of Joshimath town. This is the drainage system in the Joshimath town, and natural drainage system or nala along with the road network pass across in the Joshimath town. So the previous report of Disaster Mitigation and Management Center stated that there were 9 nalas, natural drainage in Joshimath. But due to the recent built up construction, most of these natural drains are blocked and only 5 drains are currently there, which is shown here. Further, due to the rise of tourism in the region, there has been a significant increase in infrastructure development, hotels, houses, etc., which has further increased and pressure on this existing drainage system has been created. Due to lack of proper drainage system has resulted in excess surface flow and sewage water infiltration in the ground, further aggravating the land subsidence process. Although this is our claim, but there is no evidences as of for this one. The whole incidence is also linked to the high erosion activity and toe cutting due to Alaknanda River, which many of the agencies has also confirmed. So the remarkable flood event of June 2013 and February 2021 has had a negative impact on the soil stability, creating landslide zones that increase toe erosion and slope instability along Ravigram Nala and Nauganga Nala. Yeah, this is an interesting data which shows that in the year 2006, there were only 2,456 buildings in Joshimath town. By the year 2023, 5,113 new buildings came up. So it was just double by this time. Similarly, if we look at the built-up cover, so total built-up cover at that time was 4,66,438 in 2006. By 2023, the built-up cover area increased by 8,98,843. So it is close to 9 lakhs. Okay, that much of built-up coverage took place. So which I told earlier that because of the load effect of these buildings, there could be some effect on the subsidence. Here, you can see the red color indicates buildings which came up in 2023 and the yellow color indicates building which came up in 2006. So 2006 and the red colors are those buildings which came up later in 2023. And these are the ward maps. So from ward map, you can see that in which ward, how many buildings came up. So please just consider these images. The north is towards downside. Okay. So Joshimath Town is north facing, isn't it? But here we have shown it south facing for the convenience of understanding. This is the location of damaged houses. So ward wise, how many houses were damaged? So almost you will find that in every ward there was damage of houses. Okay. And more concentration in this particular area. And this is the draft on Google Earth 3D image of 2023, where we have tried to show the damaged houses. I talked about one of the hotel which leaned on another hotel. So this is the drone image. Okay, this is a drone picture of these two hotels which actually collided on each other or which came upon each other. So later on it was demolished. And then you will find this two stands for the cracks in the road. So these are the cracks which are seen in the road. So this UAV image is for Singhdar area. So this was Hotel Mount View and Malhari Hotel. And this is for Singhdar area in Joshimath area. So in Singhdar area, you could see lots of cracks. These cracks are mapped here. And the zoom part is shown here. So these all are UAV acquired image datasets from cracked affected region of Singhdar. This is the UAV acquired ground image datasets from crack affected region of Manohar Bagh. So from Manohar Bagh area, you can see the distribution of all the cracks. And 1 stands for here, this box, 2 stands for this box, 3 for this box, and 4 for this box. So you could see the dimension of the cracks that developed here. So growth of hotel and tourist industry has strained the load-bearing capacity of the underlying debris, contributing to the land subsidence issue. Inadequate drainage system might have led to excessive surface runoff and sewage water seeping into the ground, accelerating land subsidence. Mitigation measures should include construction of retaining walls, cement blocks or erodible river banks, comprehensive drainage system and sustainable development practice. Additionally, government should invest in alternative industries to reduce reliance on tourism and address the vulnerability of the region to natural disaster, which is very important that this particular area should not only rely on tourism, rather they should look for some alternate industries also. Okay, government should invest on some alternate industries also, so that people rely on some other business. This is a very interesting paper that I want to discuss with you all. So that was what we concluded. Now let's come to the second part, which is concluded by Dr. V.K. Gehlot in this paper on creeping slopes in Northwest Himalaya and Joshimath slide, constraints from GPS measurement. So this is what he has concluded from the GPS measurement. So what he concluded, that out of 50 GPS sites in Northwestern Himalaya, 4 GPS sites in Northwest Himalaya were identified for this crustal deformation due to tectonic process. In case of Joshimath, they have used 4 GPS sites. Site motion in Indian Himalaya is expected to be southwest in the arc normal direction with a rate of up to 18 millimeter per year, which is expected. But for the 4 sites that has been selected for this particular study, it shows large motion along the local slope of the hillock, varying from 10 to 15 millimeter per year to 5 to 6 meter per year. So that much motion has been seen here. Despite the reasonable long duration of measurements at the sites, no anomalous seasonal variation due to hydrological loading or floods in the regions were observed. This is a very interesting proposition from his side. Unlike what we people were saying, that there could be some influence of hydrological loading, or there could be some influence because of the flooding. But according to his study, despite the reasonable long duration of measurement at the sites, no anomalous seasonal variation due to hydrological loading or floods in the region were observed. Among the sliding motion at 4 sites, Joshimath site showed large variation from less than 1 millimeter per day to 15 millimeter per day during 2022 to 2023. He claimed that the sliding movement was of viscous creep type. So, according to this particular work by the team, they concluded that this particular movement was of viscous creep type. The initiation of the current sliding episode of Joshimath slide is unknown, but it has been understood to be sliding since 2018, according to them. So, till now, like still it is not clear that why exactly this sliding took place or why exactly this subsidence took place. However, it can be characterized as a creep type of movement according to the authors, and as well as they have tried to find out the sliding motion at four sides, and which varies from less than 1 millimeter per day to 15 millimeter per day during 2020 to 23. Besides that, they have also claimed that there is no reasonable long duration, means no anomalous seasonal variation due to hydrological loading or floods in the region were observed. So these are few interesting takeaway from this particular study. Now let's see what IRS has done. So unlike IIT Roorkee, where we have used PS INSAR based study, here they have used SBAS interferometric SAR technique, which stands for Small Baseline Subset Interferometry SAR technique, and Differential SAR interferometric study for the estimation of rate of deformation of Joshimath area. So this figure shows a radar line of sight deformation movement between June 2019 and February 2023. The colored points reddish, it shows the movement away from the satellite and represent land subsidence of different magnitude. And you can see, I don't know whether it is visible or not, 1, 2, and 3. There are 3 marks given here. This 1, 2, and 3 stands for this 3 locations, 1, 2, and 3. These 3 cross sections. Okay. So this cross section stands for displacement in centimeter, and this is year. The x-axis stands for year. So this red mark shows, red circle shows the sudden change in movement of land surface for location 1, 2, and 3. Okay. So for 2, you can see this red mark here in 2022 as well as near to 2023. In case of location 3, you can see displacement in the year 2023. So these are the radar LOS time series deformation displacement between June 2019 and February 2023. Similarly, another scientist from IRS, so this was done by Dr. Harishankar, who did this particular study. This was done by another scientist from IRS who tried to do de-INSAR in a study of Joshimath area. And he used image from September 2022 to January 2023. Their study finds that there is a slight deformation starting from October 2022 and observed in interferometric dataset of 16 October 2022 and 28 October 2022. So these deformations are shown here. This is another very interesting work which is done by Dr. Suresh Kanoja, again from IRS, where he tried to apply the course data which was available for one particular station, the Josh station. Okay, so data from the core station Josh, located in Joshimath, installed by Survey of India, Dehradun, have been analyzed by Dr. Suresh Kanoja. Total displacement and average displacement have been estimated for this period at 4 time intervals in north, east, and vertical component. So this is for north, this is for east, this is for vertical component, and these are 4 timelines. One timeline is from 1 January to 10 November. Second is 13 November to 30 December. 31 December to 8 January, 9 January to 7 February, 28 January 2023 to 30 March 2023. And you could see total displacement in millimeter, average displacement, which is millimeter per day, for north, east, and vertical. And this figure shows these x-axis stands for Julian day. Okay, these are Julian days. And this is millimeter in displacement. Okay, again, Julian days and millimeter in displacement. Here, the dates are given. And this is the time when actually the subsidence was, it could be actually mapped here. Similarly, this is for another timeline from 1st January 2022 to 30th March 2023, where they try to capture the subsidence. Okay, this is for 11 November 2022, 2 January 2023, and 31 March 2023. How it took place. Okay. And this is again a zoomed part from 20th January 2023 to 30 March 2023, just to see that whether it is continuing further or not. Finally, they have created one satellite-based deformation map of Joshimath town. So you could see cumulative LOS deformation in millimeter, and they have given the scale where very high, high, moderate, low, and very low for different area. NGRI also did similar type of study, as I have shown in the first table, where they have tried to do again INSAR interferometric study. So what they have done SAR interferometry based ground deformation in the line of sight of the satellite using time-lapse repeat observation. This is for the timeline 15 December 22 to 27 December 22. This is for 27 December 22 to 15 January 2023. Okay. And here they have given horizontal displacement in centimeter and vertical displacement in centimeter. I'm sorry that these are very small to be read, so I'm going to read it for you. The pink color stands for Sunil area. The green color stands for Manohar Bagh area. The yellow color stands for Singhdar. The blue color stands for Marwari area. And the purple color stands for Narsing Mandir. And you could see the horizontal displacement in centimeter as well as vertical displacement in centimeter. They also tried to do flow accumulation pattern of that particular area using SRTM DM of 30 meter spatial resolution. And this is what is their result. They also suggested that transient discharge at JP Marwari slope has progressively decreased from more than 500 LPM to less than 15 LPM within a fortnight, which is being reported by everyone. They said that there is a presence of airfield fissures at greater than 20 to 30 meter depth points towards extreme dewatering of the regolith due to enhanced base flow along the basement overburden interface. So this transient revival of enhanced discharge after a short spell of rain snow on 20 to 21 January 2023 also suggests that the subsidence and associated subsurface discharge is not yet over. It means it is still continuing according to the initial report of NGRI. They have done one hypothesis. They have guessed that it would encourage a qualified guess to consider the Joshimath subsidence as dewatering phenomena, which is continuing. So they have related or they have linked this subsidence to the dewatering phenomena. Possibly the behavior of the slope subsidence and discharge during forthcoming monsoon season would reveal the culmination stage of present subsidence phenomena according to them. They have done risk zone mapping. So there are two risk zone mapping. One is high risk zone and another is moderate risk. So for high risk, it involves greater than 20 meter of regolith, and second is involves less than 50 meter of regolith, and these are the maps for that. If I summarize their finding, so according to EVRI, okay, Electric Vector Resistivity Survey, NGRI concluded that regolith cover is not uniform across Joshimath. GSI also concluded the same thing. The overburden occur in the form of concave lens with the maximum thickness is observed along the rivulet streams. Regolith cover is greater than 50 meter around Manohar Bagh area and Narsimha Temple area, and it laterally extends for greater than 300 meters. Fissures are mostly observed in the zones with thick regolith cover. However, the margin areas are also affected by subsidence fissures. So their finding is that fissures are mostly observed in the zones with thick regolith cover. At JP site, the basement is exposed near the surface with minor narrow zones of weathered rock and soil. This explains the emergence of subsurface groundwater flow as ephemeral large discharge during subsidence. So according to them, since the JP site is exposed near the basement is exposed near the surface with minor narrow zones of weathered rock and soil, therefore it explains the emergence of subsurface groundwater flow as ephemeral large discharge during subsidence. This is the finding from their MASW results of NGRI. The shear wave velocity of 12 profiles in and around Joshimath subsidence area were done. So this is what the results shows here. So the shear wave velocity of soil layers varies from 360 to 760 meter per second up to a depth of 50 meter. The top 5 to 10 meter low velocity layer is soft steep soil with shear wave velocity of around 360 meter per second. Okay, followed by 10 to 20 meter thick steep dense soil with a thin underlying soft steep soil layer over the basement of consolidated hard rock formation with a velocity of greater than 760 meter per second. So this is what they have concluded. The discrete low velocity layer is variously saturated old landslide debris material, and this low velocity is more prominent at Marwari, Narsing Mandir, Oli and ropeway areas in Manohar Bagh. The sections have large blocks of isolated gneissic rocks which have shear wave velocity similar to the basement horizon. The distribution of this low velocity layer at depth should be considered for safety measures. So that's what they concluded from their MASW results. Now let's go to the findings of CGWB. This is quite interesting. Okay, so step by step you have seen like what IIT Roorkee has concluded in our work, what we have concluded, then what IRS has concluded, then what NGRI has concluded, now what CGWB has said. So CGWB, they have mapped the location of cracks, springs and hand pumps in Joshimath town, as you can see in this particular map. The crown of the subsidence marks, according to CGWB, they have said that the crown of the subsidence marks at house of Sri Vinod Saklani. He was very much in news. You might have seen many news articles where it was first reported that a crack developed in Vinod Saklani's house, which is located in village near Upper Sunil area. Okay. So crown of the subsidence marks at the house of Sri Vinod Saklani village, Upper Sunil, and extend up to JP township at Marwari village. The intensity of the cracks is increasing from south to north. So as we move from south to north, the intensity of the cracks increases. And maximum is observed in Manohar Bagh. In Manohar Bagh area, you will find maximum. Where one of the hotels building lean over adjoining hotel building, as I have shown in the UAV image initially in our study. The depth of the cracks observed in agricultural land is up to 3 feet deep and 1 and 2 feet wide. The CGWB conducted hydrological investigation in Joshimath Town, and they have established a link between the occurrence of groundwater and land subsidence. So according to them, there is a relation between groundwater and land subsidence. So according to CGWB, the cracks, spring location, and hand pumps are aligned in the same zone, which indicate that strata saturated with groundwater may accelerate land subsidence. So this is what they concluded, that those strata which are saturated with groundwater, it may lead to accelerated land subsidence. They also concluded that the construction of buildings in the spring zone did cessation of spring flow, thereby increasing the subsurface water pressure. So which is quite possible that since there were lots of construction of building in the spring zone, so what it has done, that it has actually seized the spring flow. Since it has seized the spring flow, so there is an increased subsurface water pressure. And this increased subsurface water pressure might have actually released later on. The sudden release of groundwater reduced the existing pore pressure, and the fluctuation in pore pressure renders the land subsidence in the area. So according to them, when there is sudden release of this groundwater, okay, it reduces the existing pore pressure. And when the existing pore pressure is reduced, so there is, due to this fluctuation, there is a subsidence. So that's what is claimed by CGWB. They also did ERT survey at 5 places. And this ERT survey shows loose sediment embedded with large boulders exist up to 35 to 40 meter below ground level. Same NGRI has also claimed. In addition, the outcome of geophysical study infers that low resistivity zone, that is water saturation zone, occurs all along the cracks zone. So all along the crack zone, there is a water saturation zone. Groundwater in the area flows towards the north with a steep hydraulic gradient. And at some places of ERT, low resistivity zone occurs below high resistivity zone, which indicates that big boulders are embedded within unconsolidated water saturated sediment, and due to the sudden gush of water. So this point is very interesting. What they have said, that from their ERT survey, they have found some low resistivity zone, and this low resistivity zone can be related to big boulders. So this big boulder, when there is water saturation inside, due to sudden gush of water, what will happen? This boulder gets displaced, or this boulders gets disturbed. When these boulders get disturbed, this boulder in turn creates the cracks. So this is their finding, or this is their theory according to CGWB. That's how the cracks were developing. This is the geophysical investigation of Wadia Institute of Himalayan Geology. So according to the Wadia Institute of Himalayan Geology, they have done ERT survey in Parsari, Sunil, Singhdar, Manohar Bagh, JP Colony, Marwari. So they said that water saturation is already there. If you look at Manohar Bagh area, you will find that this particular area is highly saturated with water. Okay, so beneath this area, there is high saturation of water, and this ERT survey was done post the water which gushed out, or post subsidence, that incidence. It means still there is intact water here. Water is still there. So this thing nullifies the theory that there was some anthropogenic water, or there was some water from the tunnel. So it means water was already there and it is still there. And that's why there are so many springs in this particular area. So they have also done the geological and structural study, and they have mapped the cracks, and they have tried to find the orientation of those fractures. Okay, so let's go to the investigation of NIH. So CGWB, they have one conclusion. Then Wadia Institute of Himalayan Geology, they have also concluded another thing. Now let's see what NIH has to say. National Institute of Hydrology, they conducted a study of that particular area. They tried to find out the flow behavior of gushing water. So JP company informed that from 550 liter per minute on 6/1/2023, the gushing water decreased to 17 liter per minute on 2 February 2023, indicating a recession trend except for a sudden rise due to rainfall and snowfall on January 19 to 20, 2023. So it means the water whichever was stored there, it was released, and by 2 February it started decreasing. However, in between January 19 to 20, there was sudden rise of water to certain extent, which could be related to the rainfall as well as snowfall in that particular area. So it means still recharge is happening somewhere. It is estimated that 10.66 million liters of water were discharged from gushing water before reaching a steady state of about 17 LPM by 2 February 2023. So if we say that 17 LPM of water is the normal rate of water that should be discharged, and this much of amount of water is discharged. So from this calculation, you can make it out that it took some 12 to 15 months for this much of water to accumulate there. That's what NIH said, that if this much of water is discharged within that time, and if their normal discharge rate is 17 LPM, so it means for this much of water to accumulate, it took some 12 to 15 months. So it was getting accumulated for such a long time. They conducted isotopic analysis of collective water samples which indicate that the gush water in JP colony originate from upper reaches, which is Sunil Forest and Oli area. This is very interesting finding from NIH. According to NIH, the collected water from the JP colony, where it gushed out with 540 LPM liter per minute. So that water is not contaminated from any of the anthropogenic sources. Neither it was from tunnel. Rather, the source of that particular water is from Sunil Forest as well as Oli area. And the result is shown here. How they have done is they have done hierarchical cluster analysis of hydrochemical data, which also support the fact showing that the gush water, local springs and drains fall into a similar cluster. So according to them, this gushed water, then the isotopic data of the local springs as well as drains, it fall into a similar cluster, which indicate that the source of this water could be somewhere in Sunil Forest and Oli area, which nullifies one theory that there is no anthropogenic contamination, neither there is any water which is being contributed from the tunnel, as few people were saying that it might be because of the tunnel. So that whole theory is nullified here from the isotope study of NIH. So this is the hydrological investigation map of NIH, where they have shown all the drainage area. So here you will see that there are certain drainage channel which is coming from Oli, and this channel suddenly disappears. Okay. And there is no drainage network exists in SOI toposheet also. It means there is subsurface flow of water. Okay, there is subsurface flow of water, which also proves the theory that there is enough amount of water underground, and because of that there are so many springs also. Okay, so if there is any recharge in upper area, it will contribute to recharge of this subsurface. These are the location of springs for which they have taken the sample. So if I summarize the report of NIH, they collected 40 samples, 22 samples from spring, 3 from hand pumps, 11 samples from drain, 5 samples from NTPC sites. Okay, in 3 different field visit time, they have collected that much of data, and they have done stable isotope in water were analyzed. What they have said is that Joshimath's western part has numerous springs, indicating good subsurface storage and transmitting capacities. Then the topography and geological setting create unfavorable condition for development of permanent surface channel to dispose of water from upper reaches, because this particular topography is it's a glaciofluvial deposit, and it does not support formation of any permanent drainage, and therefore there is subsurface flow of water. Water moves in shallow subsurface channels from upper reaches to lower reaches, feeding some springs in the area, and therefore you find so many springs there. Gush water in JP colony originate from upper reaches, which is Sunil Forest and Oli area. Gush water, local springs and drains fall in similar cluster according to their HC analysis. Then gush water, local spring and drain are fresh water and not contaminated by local drains also. So there is, like initially in IIT Roorkee's theory also, we said that there is a possibility, our hypothesis said that there is a possibility that due to so much of anthropogenic activities taking place in that particular area, maybe the water has percolated down, and this percolation of water might have saturated and that might have contributed to the whole movement. But here they have said that this gush water, it's not about the movement, but this gush water, it is not contaminated by local drains also. Temporary storage may have been created due to blockage of subsurface channels. So their theory is there is some temporary storage which took place in that particular area near to JP area, and that storage somehow it broke down, it was punctured, and therefore this water came out. Based on discharge data provided by JP company, estimated storage of this much emptied in about 1 month, with a 12 to 15 month time required to store such amount of water. So they have concluded that perhaps this much amount of water has been stored there for last 12 to 15 months, and then it was released subsequently during that event. How this water was stored? So heavy rainfall in October 2021 may have changed the soil rock geomechanical and geotechnical properties, creating obstacles in the path of subsurface channel. So somehow the path of the subsurface channel might have been obstructed due to some change in geomechanical and geotechnical properties due to heavy rain in October 2021, which has facilitated the formation of the storage of that much of water. Okay, a storage of that much of water for 12 to 15 months, and after 12 to 15 months, that water came out. So this is again a very interesting finding from NIH. Now GSI has done extensive work on that particular area. They have mapped 81 ground cracks, and out of these 42 cracks are recent ones linked to the recent event of subsidence reported on 2 January 2023, and rest 39 cracks are older. The recent ground cracks are spread across a well-defined linear zone of 50 to 60 meter wide along a linear area trending north-northwest, south-southeast. The same thing was reported by Wadia Institute of Himalayan Geology also, India Geological Map by Dr. Swapnamita Chaudhary and her team. Majority of the ground cracks, irrespective of their orientation, are located in areas that are densely populated and loaded with multi-storied buildings. So this is again interesting that why there is majority of the cracks are located in densely populated and located in those multi-storied buildings only, loaded with multi-storied building. So these are a few of the pie charts which shows distribution of old and new cracks and crack patterns. Here it is shown the pattern of new cracks. So new cracks are mostly linear. Only 12 are curvilinear, 27 are linear. Crack percentage versus orientation, if you see, 44%, around 43.59% of the cracks are oriented between 335 to 350 degree. Around 25.64% of the cracks are oriented in 40 degree and 30.77% of the cracks are oriented in 290 degree. So this is what is shown according to the orientation of the cracks. This is an interesting picture which is shared by GSI where they have shown that these are such type of giant boulders. So these boulders are present both at surface as well as subsurface. So when the fine matrix surrounding these boulders are removed, so these giant boulders get disturbed. When these giant boulders get disturbed both at surface as well as subsurface, they lead to development of cracks. So that is one theory given by GSI, which is also given by CGWB, which is also given by NGRI. So this is the complete report given by Geological Survey of India. I'm not going to read everything. I'll go to the next slide. Before that, let me tell you one thing. The thickness of the loose formation in Garhwal Scout area is estimated to vary from about 40 meters to even more than 100 meters from the surface, according to GSI report. So if we summarize the GSI report, they said that majority of the recent ground cracks in linear area between Marwari and Sunilgaon are local linear phenomena. So according to GSI, this is a local linear phenomena. Likelihood of a single deep-seated circular failure is very remote. Many of us we have a hypothesis that perhaps this is a single deep-seated circular failure or there could be multiple deep-seated circular failures. So circular failure and deep-seated failure is our theory, means our hypothesis. But GSI is not accepting this particular hypothesis. They said that likelihood of single deep-seated circular failure is very remote. Recent cracks follow contours indicating detachment planes confined in Manohar Bagh and Singhdar areas. Large size deep detachment planes rarely develop in heterogeneous slope forming material. So this is again what they feel. Further, they are mapping that whole area at 1:5,000 scale. Maybe by this time it's already done. Non-appearance of new ground cracks and decrease in water discharge from new CPS point at JP Colony Marwari indicate reducing piping action. Ground subsidence space has been contained to a reasonable level, promoting ground mass stability. And ground cracks in densely populated areas are mapped. And majority of cracks found in densely populated area with multi-storied buildings. No impact on areas with scant or no habitation. Cracks spread about 50 to 60 meter wide linear zone from Marwari to Sunilgaon and eastern boundary close to existing ropeway alignment. This is what is their field survey indicates. Similarly, there was geotechnical investigation from IIT Roorkee also. So there were several tests which were conducted in Joshimath area to assess the soil characteristics, which include they have done PLT test, which stands for plate load test, dynamic cone penetration test, and direct shear test. It was led by Professor Maheshwari and his research team. So based on the result of soil fabric of Joshimath was interpreted as a complex mixture of boulder, gravel, and soil. Almost all the report has said the same thing. The matrix of boulder is supported by gravel and soils. The main reason for the subsidence is interpreted as the internal erosion caused by subsurface drainage, which may be due to infiltration of rainwater, melting of ice, wastewater discharged from household and hotels. So this is what, according to IITR's geotechnical analysis says. However, according to the isotopic study of NIH, contamination from household discharge is not accepted there. So they have said there is internal subsurface drainage which is taking place because we have some drainages which are suddenly disappearing in the Joshimath area. Based on the result of various field and laboratory tests conducted, the site were classified as high risk, moderate risk, and low risk region. So they have done the risk assessment. Then CBRI, they have done a detailed assessment of buildings, safety assessment of buildings. So as we know, Joshimath town is situated on Vakrita group of rocks overlain by morainic deposit. These are composed of irregular boulders and clay of varying thickness. Such deposits are less cohesive and susceptible to slow subsidence and landslide subsidence. A detailed study of safety assessment of 2,364 buildings in Joshimath town was conducted by CBRI. The study identified various crack patterns in buildings due to ground settlement and broadly categorized them as type 1, type 2, type 3, type 4, and type 5 in different types. So among the different types of cracks as mentioned above, the majority of cracks observed in damaged building at Joshimath region are predominantly in type 3 category, which stands for complex crack pattern in floor slab and wall, which originates at the intersection of the floor slab crack with the wall and extends upward into wall, generally in a diagonal orientation. This is safety assessment of buildings by CBRI, and this is the spatial distribution as shown here. So you can see different types of building classification is done like masonry, RCC, and others. Among them, usable, assessed further, unusable, and demolished, which needs to be demolished and what to be done in different wards. So ward-wise, they have done this study, very detailed study done by them. And these are few of the field photographs that you can see in that particular area, different taken from different sources. This is a classic photograph of land subsidence very close to the gushing water site in the badminton court of JP Colony. So you can see that whole area, okay, it's gone. Okay, there are cracks in the buildings. So now, if I need to conclude, so the point here is that IIT Roorkee, we conducted the PINSAR based study, and we could map the area where exactly deformation is taking place. And according to our mapping, the western part was more affected during that particular time. And we also tried to relate it with the urbanization using data sets from 1970s till recent time. We also got data of building, like how many buildings came up from 2006 to 2023. And among them, like how much area was covered. Then we also got an idea about how much buildings were damaged during that time. So based on that, we concluded that the deformation, it took place because of overloading also, as well as some toe erosion. IRS, they used SBAS based studies as well as interferometric study, and they have concluded where exactly deformation took place. They have also used coarse data. NGRI, they have done detailed study in many aspects and the possible behavior of slope subsidence discharge during forthcoming monsoon season would reveal cohabitation. CGWB, they have mapped the cracks, spring and hand pumps present in the area and aligned in the same zone. So this is what is the total summary of the study. I have already told in each of these subsections. So this is what all those organizations have said. But till now, there is no clear answer why that particular incident took place on that particular time. What thing triggered it is still not known. Maybe according to one of the study from GPS data, as Dr. Gehlot and his team has said, that this is a slow creep movement that keeps on moving. Okay, slow creep movement. And there are some slight, he has used one more use, which is slight wake also. So it means slow creep movement. Again, it will be stopped. Again, there is slow creep movement. So maybe that is one of the concluding remark that could be possible. Or as NGRI, CGWB, or GSI, they have concluded that the subsurface has got big boulders. And when there is gushing water, this water, if it washes away by piping effect, if it washes away the finer sediment, and if these boulders get displaced, okay, the balance is disturbed. So maybe it gives rise to certain amount of crack development in that area. That theory can also be equally accepted. And I just done one nice thing that they told that the source of this water is not from anthropogenic sources or neither from the tunnel that was constructed. Rather, the source of water is from Sunil forest as well as Olli area where recharge is taking place, and then the channels are disappearing and then it is coming in the Joshimath town as subsurface flow, and it is saturating that whole area, which is quite nicely supported by the number of springs also, which is available in Joshimath area. The presence of spring itself tells that there is lots of water saturation. Same work, which is even concluded by Wadia also. Wadia also said the same thing, Wadia's of Himalayan geology, that there are lots of saturation which is present now also. Okay, so these water saturation might have triggered, and the flow of this water might have triggered the subsidence. So there are so many theories still possible, but all these things have contributed to one thing, which is the subsidence to certain extent, development of cracks, and which has left this town reeling with this risk that there is some more bigger calamities which may take place And therefore, the government is looking forward. They have used all the agencies and they have tried to relocate the whole township of Joshimath. Not the whole, but partly they are going to relocate in some suitable area. So the takeaway from this particular study and discussion on all the studies which are done by different agencies that I have discussed, all our hilly states consist of so many towns which are quite similar to Joshimath. Maybe they are quite stable at this moment. But there is no harm if the scientific community start working on all these aspects. So we know all the verticals now, that what verticals we need to pick up and how exactly we need to move ahead with our study. So we can pick up all these verticals and let's start our study on all those different townships, and we can tell if there is some risk in future, we can tell in advance. So with that, I'm ending my discussion on Joshimath Town Sinking. So thank you so much.